I always enjoy doing these deep dive webinars, and this one's going to be a really fun one. We've got Andrew from Shortwave. Do you want to do a quick intro of yourself, Andrew?
Sure. First of all, thank you for having me here. I'm excited to talk to everyone and show you what we've been doing. I won't give you my whole life story, but the thing I'm probably best known for was before this, I founded a company called Firebase that was eventually bought by Google that does a lot of infrastructure for mobile and web developers. So this is not a developer product. It's a little different for me. It's more of a kind of a prosumer product, but it has some really cool infrastructure behind it as well, and I'm excited to talk about it.
Awesome. So yeah, we're just gonna deep dive on this for basically the whole webinar. I'll be asking questions throughout, but if you guys have questions that you want answered, drop them in either the chat if they're relevant to kind of like things that are going on the screen, or there's a little box on the right, the Q&A box with the question mark. Drop them in there if they're just kind of like general higher level questions. And we'll get to those at the end, and you can also upvote ones that you want to hear answered. So yeah, please, this will be pretty interactive. I'll be interrupting Andrew a bunch. Hopefully, you guys will be jumping in with questions as well. And yeah, I don't know. I'm always really excited by these. So with that, and this is being recorded. This is being recorded, by the way, and it will be available at the link, and then we'll put it up on YouTube afterwards. I think those are the only logistics. So let's just dive into it, Andrew.
Sounds good. So I wanna say first that this is my actual inbox right here. This isn't like a demo I prepared or something. Like these are my actual emails. So if you email me right now, andrew@shortwave.com, it will show up here. Maybe I shouldn't say that out loud. But this is my real inbox. This is a live demo here. So the thing that we launched last week that everybody's so excited about is this button up here in the corner. That you can click, and it gives you this little panel where you can talk to a conversational agent. And I think the reason Harrison invited me on here is because I talked a bit on Twitter about how this thing works, because it's a bit more, I think, than many of the examples of this you might have seen in the past, where I think we've done two things differently. One is we like really deeply integrated into the actual UX of the product. So it, for example, it knows if I open an email, like it knows what emails open and it can see it. And it knows if I start typing a draft, it knows about the draft and give me suggestions and stuff. So at a UX level, it's like very deeply integrated. But the other thing we've done is we've used AI to not just answer the questions, but also to go look up the right data to include in the prompt to answer those questions. So it gives the agent the appearance of having a full understanding of all the emails that you've ever sent or received, and your calendar, and the settings that you have, and the shortwave documentation and stuff like that. So it ends up feeling much smarter than other agents like this you might have tried.
So what does that mean? What does it mean for the agent to go look up the information? And like how is that done behind the scenes?
Well, let me start with a little demo here. So let's start with a simple question. So I'll say like, who is Harrison Chase? By the way, I have not tried these questions before, so we'll see what happens. And you're going to see it's going to actually tell us a little bit about like what's going on. So right now it's off searching for relevant emails, it's finding some, and it's giving me an answer. And this answer is based on my actual email history. So it doesn't know necessarily because my email is not super clear, but it's able to figure some things out based on what it found. So it knows we've talked on Twitter and email. It knows here's some threads that were involved. And if I click on these, it'll tell me. So I can click here and it'll show me like this is the thing that it actually found that gave me some information. And like here's some other ones as well. The way this works at a high level here is, and I'll dive into a diagram in a little bit here, but at a high level, what's happening here is we're taking an LLM, we're looking at the question that you're asking, we're saying, hey, what's the intent of the user here? What are they trying to do? And if it appears that they're trying to ask a question that would be answered by their email history, it will then go off and it will call into our backend, where we have a whole pipeline that uses a combination of a bunch of different things, some AI things, some non-AI things, to pull up all the emails we can find that might be related to that, bring them back to the client, stuff them in the prompt for the response that you're getting.
So there's some so there's some routing going on to choose kind of like the right retriever to use, and then you guys have like an email retriever because you guys own the whole email, kind of the whole email system, and you've basically now hook into that, do some retrieval, get those emails back, and then kind of like do some RAG with those emails.
Precisely. So yeah, why don't I dive into a little diagram I made here? And this is a very simplified diagram, but the basic system works like this. So let's say you get a new query that comes in. We take that query and we send it off to an LLM with a prompt that we've written. And we call this tool selection. This is where we say, hey, find me the things that matter.
Mm-hmm.
And in that prompt, we don't just include the question, we also include a bunch of contextual information about what's going on with the user's email client right now to help disambiguate what the person is talking about. So for example, if I have a thread open at the time and it's about LangChain and I say, hey, find me similar threads, if someone who was sitting next to me, they would know I'm probably thinking about LangChain. I probably want to look up some LangChain stuff. But if they weren't sitting next to me, they wouldn't necessarily know that. And we want to give that appearance. And so in the tool selection, we have the history of the conversation that you've had. We have a prompt that we've written, but then we also have like other information about the state of the world, your time zone and some settings and the threads that are open and the drafts that you've written and stuff like that, so that it's able to figure out what you're talking about. Like if you say this, it knows what this is. We then go off, and from that tool selection, we go and we load a bunch of things in parallel. And we have more than 3 tools. There's a bunch of tools, but each one of those is kind of a separate code path, which is great from a modularity perspective. I think one of the things we've really struggled with is like, how do you make an AI system not just a total black box? Like how do you put like normal computer science into it and break things apart? And this is one of the things that lets us do this. So each one of these pipelines has a very simple responsibility, which is find the right data to stuff in the main prompt at the end related to this particular type of question. And we have a bunch of those, and I'll go into the AI search one, which is the most interesting one, I think, later. And then the output of those gets fed into a prompt at the end that includes some wording that we wrote to make it sound appropriate for an email assistant. But then all the stuff that we pulled from that information and some information also will be extracted at tool selection time, puts it all together, calls off to an LLM. In this case, we're using GPT-4, and we get back the streaming output from that. We do some post-processing on it, so we like linkify things, and we do like markdown formatting and a few other steps there, and you get your response. So this is kind of the system end to end here.
Cool. A few questions just to dive in. So you mentioned using GPT-4 for the response. Do you also use that for the tool selection as well?
We do right now. We tried a bunch of different things here. The downside of GPT-4 is twofold. One, it's kind of slow. And so you'll notice when in our app, if you press enter, there's going to be a little ... there for a second for like 600 milliseconds. And then it switches over to say like, answering your question or looking at the emails or something. And that's our tool selection running. And one is kind of slow. The other, it's really expensive to do this because we're not just, every time you ask a question, we're not making one LLM call. We're actually making like 10 because a bunch of the tools also do LLM calls as well. So there's a lot of processing going on every time you do this to make this thing work. But we tried, Palm, we tried GPT 3.5, we tried Claude Instant, we tried some open source stuff. Like we tried all kinds of things. And what we discovered was if you really want it to be able to disambiguate, like if you want to make it so the user doesn't have to like very carefully phrase everything they say to disambiguate what they're talking about, if you want it to really feel smart, GPT-4 was really the only one that we could get to work across like a wide range of tools, across a wide different set of inputs. And so that's what we're using.
That makes sense. And then I'm curious about the tool selection bit as well, because I think that's something people building on top of LangChain are really interested in. Like, do you select multiple of them, and then what are the inputs to the tools? Like, do you have the LLM generate an input to the tool, or is the input to the tool always kind of like the previous contextual information that you use for the tool selection, anyways?
Yeah. So let's start with talking about what the inputs are to the tools are here. So it depends on the tool. For some of them, they're very simple. So for example, for documentation right now, we do the very simple thing, which is anytime we think you're talking about the shortwave docs, we just embed like a single version of that, which is probably more expensive than it needs to be. But like, there's no arguments at all. It's just like, oh, you're talking about the docs. Here's all of the docs. We're gonna stuff the whole thing in the prompt. Other ones are a bit more complex. The most interesting one, and I have a diagram here for this as well, is our AI search. So this is where we shine. So there's a bunch of folks out there that have like talk to your individual email features. There's a bunch of them that can do like run basic like Gmail search. Like Bard put out a thing where like you can like look up emails, and those may be doing some aspects of this, but no one that we know of has this piece, which is let's actually use a bunch of AI tech to do lookup. And the way this works is the arguments to this are well, it starts with this thing called query reformulation, where the arguments to this is the same inputs that we have for the tools. It's like all the context, the state of the world of like what threads are open, what drafts you have in your settings and the time zone and all of that. And this time, rather than us asking the LLM what tools should we use to answer this question, we are asking the LLM, hey, take this whole giant prompt and this user's long conversation. There might be like multiple messages that it sent, and I want you to condense this down into a single question, right? That includes all of the relevant information that you need to answer this. And the reason for it is that for the things in the next stage, if you actually gave them like a whole chat history, or you gave them a whole chat history and the thread and the draft, like all of this information, they would struggle. Partly because they're using like faster, cheaper LLMs. Partly because for like embedding, like you don't want to embed all of that context. You want to embed just the relevant stuff. So the query reformulation take is distill everything the whole chat history and all this context, distill down to like the single thing that the user is trying to ask right now. And this was, I think, a big win for us when we figured out to do this. We tried a bunch of other stuff before this, but when we figured out, okay, first step is actually to distill this down, it made things a lot easier.
I think just to maybe put this kind of like in context for some of the LangChain users as well, I think this is really similar to some of the stuff we have around reformulating like the chat history, which I think is like relevant for other reasons. Like if you use kind of like pronouns or something to say like what was he talking about, like who he is, like is really impactful for what you want to search for, right? And so I think it's like a similar idea here, where you take the context and then you generate some query that has everything. One question here is like, have you considered splitting it into like multiple queries? Like we've seen that sometimes be helpful when people are like, this is for like more like research style agents and there's less less latency concerns. But like basically if someone asks like, what like how do the features of like Shortwave compare to the features of Gmail or something like that, you maybe want two queries, one that looks up Shortwave, one that looks up Gmail or something like that, rather than one that combines the two. Did you experiment with this at all, or was that ever a consideration?
Yeah, we did play with this, and our experience was, at least at the time, that anytime we had sort of like multiple stages where the output of one stage would feed into the input of the next stage, it was really hard for us to avoid like error propagation issues. Like if at each stage you were counting on it like outputting the exact right set of information for the next stage to do its thing, like, and you chain a bunch of these together, it would start to break down. And so we said, hey, let's just throw some money at the problem. And rather than chaining the stages together, let's get all the information, let's stuff all of it into the prompt, and then make GPT-4 at the end with all the context make the call. I think that the downsides of this is it's more expensive. And it probably is like less flexible in what it can do. We can't do things that require like a lot of different things to plug in. But for the set of things that we wanted to launch with, we felt like it could do a reasonably wide set of things in a fairly reliable manner. So this is where we landed. This is something I do want to play with later, because there are definitely some downsides of this approach. But at least the LLMs of the time, we didn't feel like we're delivering the low error rates we needed to make that work.
Cool, makes sense.
Yeah, I'd be curious your thoughts here, if you've seen more success there than I have, or if you're bullish on this getting easier over time.
I mean, I think specifically with like regards to like the error propagation of steps feeding into other steps downstream.
Yeah.
I think I'm bullish on this getting easier over time. Yeah, for sure. I think like another thing is just like generally as you do more and more steps, the context kind of like builds up, and with more context, the LLM at the final answer, if it's like doing multiple steps, it almost like needs to track what it's doing at each step, and it gets a little bit confused. We've sometimes seen, like I think this sometimes happens with like long running agents where it's kind of like thinking through its thought process and doing one step at a time and then one step at a time. And so I think like the way, like if you just kind of like circumvent that, and even if it's the same amount of context but it's just like a single step rather than like multiple steps that it has to like reason through, I think we've seen that to be a little bit better. And then yeah, I mean for the problem of like query reformulation in general, like I think yeah, we see people doing this a bunch. Like oftentimes the conversation or the question that people are asking is not what you want to be passing to your retrieval engine, whatever that might be. And you know, we've even seen people write like prompts that are specific for like Amazon Kendra Retriever, because the Amazon Kendra Retriever has like a specific way that you want to pass, that you want to query it, right? And so I think query formulation is a big is a big thing.
One of the things I'm excited about trying going forward is at the time of reformulation, there are still, like for us, there's still a lot of like relative things in the reformulated query. So for example, dates and times are one of these things where, you know, the reformulated query might still say like next Tuesday. Yeah. And we probably go farther and try to start replacing all of the sort of relative phrasing in there with specifics. So like maybe our in the future query formulator always encodes like an actual date in it, or an actual name, or something like that. We haven't tried that yet, but
how would you think about doing that? Like I would imagine that would mostly be prompt engineering and kind of like saying like today's date is blah, and you should always reference dates like, you know, by their exact kind of like day rather than relative things. Is that how you would think about it, or is there some other approach?
Maybe our experience is that even GPT-4 really struggles with date stuff.
Yeah.
Like it's not so good at the math. And like I was talking to the Clockwise folks, they're building an AI agent to do scheduling, and like the way they've set it up is all of the actual data arithmetic is done in their code. Like they have a whole framework for doing it, but and the LLM sort of like finds the dates and then hands it off. So maybe there's some, you know, maybe there's some hybrid approach there where we can do the data arithmetic in, you know, date code and do the rest with the LLM or something like that. Or maybe the LLMs will get better to the point where that doesn't become a problem anymore.
That's what I was gonna say. Yeah, hopefully that'll just get better.
Yeah. The difference between GPT 3.5 and 4 is dramatic for this type of thing. I imagine, you know, in a year or two, this will be a different story.
Yeah. On this slide, just because I don't think you've mentioned it yet, what's the feature extraction bit? Like I get the embedding model, vector DB, and I'm glad you put Pinecone there because I saw some questions about your tech stack, and so maybe we can get into that later. But like, what's the feature extraction bit?
Yeah, I'm happy to talk about the workings of all this stuff. So, you know, to be thorough here, the query reformulation we also do with GPT-4. Once we've done the query reformulation, we run each of these sort of vertical slices we call a fetcher, and it's basically what we're trying to do is build up a set of candidate documents in memory that might contain relevant information. So if you look down here, like this all fans together here down at the bottom, and each one of these uses sort of a different technique to find relevant documents. And obviously I'm not listing them all, but the one on the far left, I think, is probably the most interesting, which is the kind of standard embedding plus vector database retrieval model, where we take the reformulated query, we have a model called Instructor XL. It's an open source model. You can just get it on Hugging Face. But we embed that reformulated query. We look in our vector database because we've already embedded all of your existing emails and put them in there. We find things that are, you know, similar cosine similarity, and we pull those into memory. But the thing is, that's really good for answering questions where the answer is contained in a document that like looks similar to the embedding of the question, which is often true, but is often not true as well. And so the other pipelines the other fetches we have here are basically going after other avenues of attack that we've seen work. So as an example, we have an extractor around email addresses. So if you actually use an email address in your query, we look at that and say, oh, let's just pull a whole bunch of emails that were sent from or to that email address, and let's pull those into memory too. We have one that looks at labels, so you can reference your labels and pull those in. We look for keywords. We look for dates. There's a bunch of things. So we say, okay, the thing on the far left, this is like the normal kind of vector DB thing, but all the rest of these are using an LLM to extract search criteria and then looking for those particular search criteria. At the end of this whole thing, we have a big pile of these, right? We have like thousands of emails at this point. We used to try to just stop here and see if it would work. And the problem here is like, if you have thousands of emails, like you can't reasonably stuff that all into a prompt, even if you're using Claude, right? Like it's going to take forever. So you need to cut this down somehow. So that's, I think, where things get more interesting, where we have a couple steps to this. So first is we have just a bunch of like hand-rolled rules that we use to call this down. So we look at things like, if things are labeled as like marketing promotions, we're gonna weight against them. They're usually less relevant to people's queries. We do time-based biasing depending on the question. So actually we use this isn't actually shown in the diagram here, but we use some of the features that we extracted earlier to feed into the heuristics. So we say, for example, like, is this a question for which the user is probably asking about something recent? So for example, if you say like, when was my last flight, right? The LLM can tell you they're probably asking about something that didn't happen that long ago. And so then in the custom heuristic phase, we're like, okay, we have flight data for the last 20 years, but we're going to weight the things that happened more recently. We're going to weight them more highly. So we have a whole bunch of custom heuristics that sort of address, and this has just been, things that we've learned through trial and error over time. So addressing the sort of biases that we need to like work well in an email system. And then we take the output of that and we feed that into a cross encoder that's just like an open source model running on our GPUs, whose purpose is to say, for a given document and a given question, how likely is this document to actually help? So once we've culled this set from thousands down to hundreds, the cross encoder then runs on those hundreds and calls this down to like 30 or 40. And that actually does fit into the prompt. And then we send those back to this diagram over here. And we plug that in to the main prompt and we can answer your question.
That makes sense. That makes sense. And is that cross-encoding model just something kind of like off of Hugging Face, or did you guys fine-tune that in any way?
It's just a thing off Hugging Face right now. We use a model called MS Marco that is trained on Bing data that Microsoft open source. So it's a bunch of Q&A data. This is also an area that we are planning to invest in. The model works pretty well for finding text that answers the question. But often the question you have are things for which the metadata is really more interesting for answering the question. And because the model wasn't trained on email metadata, it can't really help you with that so much. So one of the areas that we're looking for is like, how do we make this cross-encoding model smarter for things where the metadata matters, where the dates and the senders and the labels and stuff like that are really important.
Yeah. Interesting. Have you tried just putting the metadata in with the text and cross-encoding on that?
We've played around with a bunch of stuff like that. We haven't found success yet, but we haven't given up.
Cool. Okay, there's a few questions in the chat, and so maybe we can cycle through them now. I don't know if you have other things as well, but I figured it would good stopping point to check and answer some of these. Is this using structured data behind the scene for data retrieval? I guess it kind of is, because you're extracting some of the attributes, and then, if I'm understanding the question correctly, I think it's asking. I think you are, because you're extracting features and then doing that in some way.
Yeah, If I think I understand the question the same way you do. Yeah, we are taking an LLM or a bunch of LLM calls, looking at the query, trying to figure out certain types of structure, and then from that structure, we are running normal searches of various types.
What LLM are you using for tool selection? It's impressively fast.
GPT-4. And the key here is keep your output tokens really short. It's, you know, if
How do
if
you
you're
do
only
that?
uh, we are only spitting out like one. The output is simply one token basically per tool, and it's just like a comma separated list, or maybe just like a space separated list.
Got it.
We used to had more structure, and like we were doing like XML tags and stuff, and we cut it down to be like, it's like, 3 tokens on average or something.
Got it. And so then, like, do you have like tool names that are like, I don't, like, the one token is very short, so they can't be like that human readable, right?
It might be 2 tokens. Yeah, they're not particularly
Yeah.
verbose. We have a bunch of scripts that we use to like test these, and we tried a bunch of different stuff. We tried like spitting out like numerical values. We tried having it like just explain its reasoning and then split out numerical values, and settled on this approach because it works almost as well. Like the best one is explain your reasoning and then spit out numerical values and then have some weights applied after that. But like if you wait for it to explain its reasoning, that takes a long time.
Yeah.
So what we found is if you just spit out the tokens, it's almost as good and it's way faster.
And just to dive into something you said around testing, like I think a lot of people are wondering how to test these things. I imagine the tool selection is basically kind of like just classification where you can maybe select multiple things. So I'm like, evaluation for you or testing for you probably isn't like terribly difficult, or because you're just like, did it get the 2 tools that it was supposed to get, and then some kind of like precision recall kind of like trade-off calculation. Is that correct, or are there some nuances that I'm not thinking of?
Testing is, I think, like probably everyone you talk to, we're bad at testing. Everyone's bad at testing this stuff. It's a combination of, we have a bunch of Jupyter notebooks that we use to like just test specific prompts, where we say, okay, here's the thing to evaluate the tool selector, and here's the thing to evaluate like this particular feature extractor.
Yeah.
And for that, we just have, hand rolled like a whole bunch of specific test cases based on alpha user feedback that we've gotten.
How many test cases do you have? Like, is it like order 10, order 100, order 1,000?
Order 100.
Yeah.
It's not a huge number. And then the other test that we do is like end-to-end tests, and that's just manual as well. Like we have a set of golden, like, hey, we know these things should work roughly, and we go through them periodically. This is actually a major focus for us right now, is figuring out how do we automate this better, especially automate this in a way that isn't like, complete a waste of time as soon as we swap a component out, because the system is evolving very quickly. I think, one of the reasons I'm being so open here is like in 3 months, it's probably going to be a totally different system. And so, yeah, we're trying to figure out like, how do we measure this stuff and test this stuff in a way that like will, the data will accrue and be valuable over time rather than be obsolete right away.
And for the end-to-end tests, like, do you do anything automated, or is it just like look at or I guess, do you even know what like the expected answer should be? Because if you're running it on like your emails change kind of like, every week, so the answers could change every week, right?
Right. Yeah. So I did. I'll give you a fun example of this. So actually, I'll show you. So the blog post that we wrote for our announcement, actually, I used our AI assistant to help write the blog post, which was super fun. And before I started, I said like, look up user feedback for our AI assistant and use that to suggest an outline for a blog post announcing its launch. And I ran this thing before the launch, like a ways before, and it gave me one set of answers. But then I started sending a whole bunch of emails related to the launch to press and various partners and stuff, and my email history got polluted with lots of descriptions of me talking about what our blog post was about. And then it started just regurgitating my own talking points, became like much less useful for me. So I thought this was kind of a fun example.
Yeah. So how do you think about testing that end to end then? Are you just like, do you even have ground truth answers, or do you just have like queries that you run and then look at the results and see if they seem reasonable?
Right now it's the latter. We have we have sort of golden test cases we expect to work, and we update them over time. We're working on that more kind of automated bit. We also, like, we have in our test environments, like, we can load specific sets of email history too, right? So I don't have to run this on my personal inbox. We can also say, okay, given this, frozen in time set of email history and these questions, like, we should be able to get specific answers. But yeah, it's just like a set of golden test cases right now. And my experience has been, when I go and have lunch with like other AI founder groups and stuff and sit down and ask them, like, seems like this is what most people are doing right now. Automated testing is real hard.
Yeah. I think we've seen kind of people do it at the individual prompt or individual kind of like, that level. But end to end, and end to end, I think it's a lot of looking at stuff. What is your tech stack? So you've talked about OpenAI, you've talked about MS Marco, you've talked about Pinecone. Any other kind of like big components?
Yeah. So the left portion of this, like the tool selector and the main prompt, most of the code here is actually running in our client. So this is a bunch of TypeScript code. We do proxy it through our backend to, before we actually make the calls over OpenAI. But this is actually just like TypeScript code on our client. And the reason for that is we need easy access to like all the context, and that stuff's available in the client. On the back end here, we're running on Google Cloud. We got a bunch of GPUs and a bunch of servers there and a bunch of big databases. We're using for our models, we're using InstructorXL for embeddings, which is pretty awesome and pretty fast, and much cheaper than using, say, OpenAI's embedding model. We're using Pinecone for our vector database. We're using MS Marco is the encoding model that we're using here. What did I miss? It's all Kotlin on the back end, which I know is kind of weird, but we like JVM languages and we like Kotlin. So
does Pinecone even have a Kotlin client, or are you just using APIs directly?
I don't remember the answer to that, honestly.
All right.
I remember we were using some client that was really slow, and then we swapped it out for something much faster, and I don't remember what we did there, but we made it work somehow.
The next one's a fun, more open-ended one. If you had a 1 million token context window, what would you do? Would you do anything different? Also, is another way of that, because then you've talked a lot about speed, and so that's also a consideration that goes into this.
So I think my answer is it depends on, I think, two things. One, what does it cost? And two, does its reasoning get worse with size? And right now for us, actually, the limiting factors for us are the latter two. Like if we stuff every prompt full of stuff, I think in many cases, like, there's extraneous information that makes the reasoning worse, and it's really expensive. So we're trying hard not to use more tokens than we could. I think if the reasoning didn't degrade, and if it was really cheap so that it was just very practical, I think I would do a fair amount differently. I think a lot of the tool selection would just go away, where I'd say, oh, okay, many of these don't need that many tokens. So a good example would be like the docs, right? Like our docs description is like 6,000 tokens or something, right? Like, we'll just shove that in every time. Why not? So I think a lot of that would disappear. We probably couldn't fit your entire email history. Like, your email history is a lot more than 1 million tokens, probably, at least for me it is. So we'd probably still need the backend retrieval, but we could be probably much more generous in what we include, rather than trying to cut down. Like, right now, a typical question, like, if we ask, what are some fun things we shipped recently? By the way, it shows you what it looked up. If you're wondering, like, what emails did it consider in the answer, it'll tell you. So right at the top here, you see it says where it says based on 16 emails. If I click that, we'll let it finish. Yeah, if I click this, it actually tells me here are the emails that were considered, and here are the emails that we end up putting in the prompt. And so it's actually like this email thread here at the top is the one that it ended up it's 29 emails it inserted. So, and it only chose 16 out of those. So at like a typical response, it's going to be, 10 to 50 emails or so that we actually include.
Nice. Next question up, does this whole pipeline run on every chat reply versus are replies processed differently? I guess I think this means if you're having like a conversation, is there any difference in handling kind of like follow-ups, or is it the same?
We run the whole pipeline every time. We used to not. We tried various different things under the belief that, hey, like if you're continuing the conversation, maybe we don't need to like retrieve context again, or maybe we can like be faster in some way. But like I think that what we discovered is people's topics, their conversations evolve over time. They ask follow-up questions that need additional data, and the best way to like reliably give good answers was just to build a pipeline that works the same for every question and just deal with the cost and latency of that and try to make it fast. And so that's, every question is the same right now.
That makes sense. The next question is about kind of like costs. So obviously functionality is most important, but curious how you think about modeling costs of embedding everything and using GPT-4 / other models. I know you've touched on this a little bit throughout. I don't know if there's something you would add.
So I think right now the biggest cost for us is actually the GPT-4 use at serving. It's only slightly more expensive though than the rest of the pipeline. We spend a fair amount on GPUs to do the embeddings. We spend a fair amount of GPUs to run the live query with the cross encoder and stuff. We have actually two different pools of GPUs. We have the pool of GPUs that does the embeddings, where we're not so latency sensitive. We're trying to be cost efficient. Then we have a much higher performing set of GPUs that we use for the live serving, because we're much more latency sensitive there. Pinecone is also a pretty big cost driver for us. And they, one of the reasons we chose them is they have, in theory, a new platform coming out very soon where they're going to start separating compute and storage. That should drive costs down significantly. So actually, if I can briefly plug Pinecone, there's a couple cool things that Pinecone has. One is they should have a serverless platform soon that, if you have a lot of vectors, should provide much better cost performance for you. For someone like us who does few searches and has lots of vectors. The other great thing about Pinecone is they do namespacing. So for someone like us, where we have many users that you don't want to query across them, they give you the ability to separate those in a way that doesn't affect performance. Like there are other solutions that let you do something like this, but the actual way it happens is like a post filter. Like they'll go do the cosine similarity search to retrieve all the documents, and then they'll throw out the ones that don't fit your filter, and that ends up being really slow. So we looked at using PG Vector with Postgres for this. We looked at several other ones, and we looked at using Elastic's new stuff, and none of them could provide the performance profile with the level of sharding that we have, except for Pinecone. So that's why we use them.
I know a lot of people are always asking about vector databases, so I think that was I appreciate that insightful kind of thought on it, because I think it's always top of people's mind. The next question is a good one as well. Is there any self-learning? For example, if I ask the agent to draft an email, then I correct the tone, will the tone be different next time?
Not in that sense. This is something I would love to do, right? You can have a conversation and you can teach it how you want to work. We do have a feature that can help you in this particular case, though. So if you go to your settings and you go down to compose, we have this AI assistant writing style here, and this is kind of fun though. And the way it works is I'll reset it so you can all watch. If I click personalized writing style, it's going to take a whole bunch of emails that I've sent in the past. It's going to send them off to an LLM, and it's going to have it describe how I write. And one of the fun things about this feature is it's really direct in its descriptions sometimes. So for one of my co-founders, his description came back where he had said, he is verbose to the point of being annoying, which we thought was really funny. And then we were like, okay, do we want to maybe have it so it doesn't insult people when writing these descriptions? But anyways, this actually works pretty well. And I think this has two benefits here. One is it's a very simple implementation. If you wanted to do writing style stuff yourself, this sort of approach actually works pretty well. The other, though, is I think the more important one, which is a product benefit of you actually maybe don't want the AI to write in your style. What you probably want is to write in your ideal style. And so you can do this, have it generate the thing, and then be like, well, maybe I don't want to say, this one's, so I say I'd love to, so I'm just going to remove that. I won't do that anymore. And then I have my new writing style.
And this,
so this is,
and this gets inserted into the prompt as like a system message or something like that.
Yeah, so this is one of our tools, actually. So when we look at the thing and say, oh, they're trying to get the AI to write a thing, we then pull in your writing style and insert that.
Got it. Okay, that makes sense. I like that. Yeah, we've seen. I think the idea, we did a webinar with Greg Comron a few weeks or a month or two ago around basically this idea of like tone and imitating kind of like people's tone, and I think this is super interesting. I think I like the point that you made that sometimes you don't want it to copy your exact tone. You maybe want it to be an idealized version of your tone. I think it's the idea of automatically extracting it is also good, because if I was asked to like write down my tone of how I wrote in emails, I don't even know where I'd begin. So I think having a language model kind of like look at it and start. One thing that we both, the genesis of that webinar was actually fine tuning, because basically I do think that if I want to like learn a person's tone, fine tuning arguably seems to me that it would work better than kind of like some system prompts or even few shot examples. Have you played around with that or thought about that at all? I'm guessing that's not super feasible at your scale, but
we have. There's some tech we've been looking at that I'm not gonna share here actually, but that lets you do kind of scalable per user fine tuning. And we may release something along those lines. I think the trick is, how do you make it cost effective and performant if you have a whole bunch of little fine-tuned models like that. And I think also the product experience of, maybe there's benefit to having it be more of a textual description. So that's an area of research for us right now.
Yeah. All right. Some next question: can it work with Llama 2 models instead of GPT-4? I think you've already answered this. GPT-4 works the best.
Yeah, I'm sure you could build a system like this with Llama. I don't think it would work as well.
The next question I actually think leads to an interesting place. So are there any plans to support email providers other than Gmail? So this isn't Gmail, right? This is Shortwave.
We only work with Gmail right now. So we don't you don't get a standard email address. We plug into your Gmail account. Our primary focus is like Google Workspace users. We're going after startups using Google Workspace for their email and trying to give them like a better experience. I would love in the long term to support other folks. Like we get a lot of Microsoft ecosystem people being like, hey, when are you going to help us out? And a bunch of people who are like, hey, I would rather like not have my data in Gmail, like self-hosted version, or do you have a cloud solution that you guys provide? We want to do all of that, but I think it's one thing at a time. I think our focus right now is, we want to have the world's best, most capable email AI assistant, and that is a tall order, and that is where we are focusing right now. So.
And so along this vein, like, how do you think about like Gmail potentially building something like this in there and having it kind of like be natively integrated with Gmail? And I think with Spotify announcing kind of like their translation service yesterday, there was a lot of startups doing kind of like translation for kind of like podcasts and stuff, and now the platform kind of like builds it in. And so how do you as like a product and an entrepreneur think about that kind of like trade-off there?
Yeah, so I think it's helpful back and understand that I was a Google employee not that long ago. My previous company sold to Google. And when I was there, a bunch of the people that I recruited onto my team were ex-Google Inbox folks, because they built this thing that a lot of people loved, and they innovated on the UI of email a whole bunch. And it, for various big company reasons, did not go well. Ended up getting shut down. And while we were there were some refugees from that team that came over and joined our team. And I got, I think, a good appreciation for why it is so hard for a big company to take a big old product like this with bajillion stakeholders and like actually do meaningful innovation. And I think you see a lot of noise from Google around this type of thing, but I don't think the rubber is going to hit the road like some people think it will. And a great example of this is go try Duet AI, which is like the enterprise AI thing that they launched recently. It's $30 a month. It's only available to enterprise users. We signed up. It does almost none of this. And the only thing it really does is it does some of the writing stuff, but the writing stuff is not particularly good. I was not impressed. And they claim there's a bunch more stuff coming. We'll see. I think we are ahead of them right now. I think we have a very good chance of staying ahead. We're going to keep moving super, super fast. And I think even if they somehow manage to keep up just on like the technical innovation side, which I really doubt, there's UX considerations where like the actual UI of Gmail has not changed in a meaningful way in a very, very long time. There's good reason why it is very hard to change. So like I'll show you actually one of the good arguments here. So if you go into Gmail and you click on the settings, like there are 10 billion settings here. And the way to think about these settings is every one of these settings is a stakeholder somewhere at Google that wants it to work a certain way. And so if you're a PM there and you're like, we need to like totally reimagine the UI around AI, good luck. And we aren't constrained by that. So if we want to say, you know what, we're gonna say there's a little thing that pops up from the side and everything is built around this and everything plugs into this and this AI has knowledge of everything and can do everything. Like that is something we can, the whole company can rally around that. We can focus on that in a way that it's really tough for Gmail. So our plan is just to run ahead of them. And we've been doing it so far and we're gonna keep doing it.
Sense. What was your inspiration about query reformulation?
We tried a lot of stuff. I don't know that there was any major inspiration. We tried a bunch of stuff. We talked to a bunch of people. We looked at what other people were doing. I don't remember the particular spark, but it worked. So
cool. All right, one more question and then one softball to end it because I think we're running a bit short on time. What are you doing, or are you doing something on preserving the privacy on the content of emails? This is maybe like the #1 question we get from everyone around Gen AI. So I'm curious to hear your take on it.
Yeah, this is absolutely top priority for us. Obviously, like your business email is super, super sensitive. We're doing a bunch of stuff. So the first thing I want to note is if you don't use the AI assistant, nothing leaves our system, right? So we don't embed things unless you ask us to. Even if we do embed things, we embed stuff on our own GPUs. We're using an open source model, like we're not sending that stuff off to OpenAI. We do have one external service provider, which is OpenAI, which for the questions you ask, we will send just the relevant emails and the question off to them. And so, I think one of the big reasons we decided to move forward with them is they changed their policies around the way they do training and stuff so that they are not training on the emails that we send them. So we've gained some confidence that they are a trustworthy provider from a privacy standpoint. But even then, we only send them the questions and the relevant stuff. And if you don't use it, it doesn't go anywhere. We are not currently training any models. We may train models, but we definitely won't do so without like very clear communication around what we're doing and what kind of data we're using. We probably won't start with any generative models. So like the models we train will probably be like feature extraction models and cross encoders and things like that, for which like the risk of like something you type getting generated out to someone else is not there. So yeah, we're being very careful about this, very thoughtful about this, very much top of mind.
Awesome. And then final question, and take this whatever direction you want. What are you personally most excited about in the future of Shortwave? Like, what can you tell people? How can people try Shortwave? Yeah.
There's a lot there. So one of the things I want to mention before I go talk about the AI stuff, because obviously I'm going to talk about AI stuff, but there's a lot of cool stuff in Shortwave that has nothing to do with AI, right? Like that we have some strong opinions about like how to get to inbox zero and how to manage your inbox, and we give you like to-do list type features. So for example, like I can take my emails and be like, hey, these two things seem related. Let me like stack these up and like, add a note. And then I can take that and I can like drag it around my inbox and be like, okay, that's top priority. I'll put it up here. So we put a lot of thought into like, how do we help you effectively manage your to-dos? How do we help you, automate things? So we have this thing called delivery schedules where you can like say, I only want these emails at certain times of day, or hey, I don't want these emails in my inbox at all. I just want them to like auto archive and go to my search history. So there's a lot of like automation and like task management stuff that we have built in that has nothing to do with AI. But the stuff I'm personally most excited about is definitely AI. And I think some of it is just improving the capabilities of this assistant. So like if you try it today, it does a decent job. It'll answer your questions most of the time. It'll give you pretty good answers. It'll draft emails that are pretty good, but it isn't quite at the level of like an actual human assistant. But I think that's where it's going. Like I think all of the trends are with us. We're going to have LLMs that get smarter and smarter. We're going to figure out the algorithms better and better. The GPUs are going to get cheaper, so we can be considering much more and more data over time. So all of those trends are with us. I do think we can get to the level where this sidebar really truly is a reasonable replacement for a huge chunk of like what a human assistant might do for you. The other set of things I'm excited about are the things that maybe on the AI side that don't necessarily fit neatly into the sidebar here. So here's an example, like long-running jobs. Today, everything is like question response, right? What if I could say, hey, I want you to go look at, don't just do the vector database thing. I want you to like run my entire email history through an LLM, and I want you to create a report that like analyzes in great detail, like everything that users ever said about the AI system. It'd be really cool if we could be like, cool, we're going to spend 3 hours and it's going to cost you $20 and we're going to generate that report for you. And we have the data, we have the technology to do it. It's just a matter of building it. So I think long-run jobs is one. I think AI-based automations. So right now, our AI system can't actually do anything. All it does is like suggest actions you can take, and there's security reasons for this, right? We don't want people to be able to like prompt inject you and stuff. But I think there is potential for us to be able to do like things like set up a filter where you can describe, to the AI, hey, emails that look like this sort of thing, I want you to do this, but label them, or like have them skip my inbox, or set up an AI autoresponder, right? So like you go on vacation, you're like, hey, for people on my team, send them this message. For people that are external, send them this message. For if you get questions of this type, like respond, using the notes in this document, link to the document. So anyways, lots of fun stuff.
Sounds like there's a lot. Appreciate you taking the time to come on and talk about it. I really enjoyed this. This was great. I think the level of detail that we went into was awesome. Yeah, thanks for joining.
Yeah, thank you for having me. This is a lot of fun. Appreciate it.
All right. And with that, we're done. Thank you everyone for tuning in. See you at the next one.
Cheers all. Thank you.